So let's talk about how web applications work and why they're so insecure in general terms. So of course, now we have a lot of things going on the web. There was a time long ago when it was just static web pages like mine that are just like a poster on a bulletin board where everybody sees the same page. But now you got banking and social networking and everything else there. And that means users can supply input for logging in, for putting up Twitter messages and other things. And that's the problem. That input might contain malicious content. So like I say, Web 1.0 was just a static image or something where everybody looks at it, and that was relatively secure. There were some flaws with it, but it didn't have the problem of data coming from the user because all the user could do was send a request to see the page, and they would just see the page. But almost nobody has web pages. Modern web apps have all this data coming in from the user, logging in and social network content and everything else. And a lot of the apps are developed in-house. They use a framework of some kind, a software that comes from a company, and that might have vulnerabilities. But the worst problem, of course, is the code written by a company because those people are typically amateurs. They're not that savvy about security. They're more likely to make mistakes. So there are probably some scripts written by your developers that are making errors. So you can do shopping and banking and gambling and many other things online. And all these things involve taking unstructured data from users and then trying to store it on the server or process it on the server. Many email and human resources and everything else. And as I mentioned in the news section, now not only is that stuff being processed by many different applications in different languages, now a lot of it is being processed by AI. And AI has a whole bunch of new security risks that are only beginning to be understood. Anyway, so the HTTP, yeah, that happens a lot here. Our heating system is like from 1908. So it's steam heat, and it's very primitive, and it makes a lot of noise. Also, they turn it on the warm days and not on the cold days. This place is very strange. Anyway, so HTTP is a very simple communication platform system, and you'll get used to it here. You send a request. It's connectionless. The server gets a request, it sends an answer, and it's done. It doesn't remember who you are or maintain any state. That makes it efficient. It doesn't use much memory. It does mean that it has a problem. If you do something like logging in, and then you make a request to open like your email, it's forgotten who you are. You have to somehow send an identity proof with every request, and it's pretty easy to trick it into misidentifying you and showing you somebody else's stuff, and we'll be doing that quite a bit as we go ahead. So breaches are common where people lose their data on the web, as you know. The number one vulnerability on the web until about 8 years ago was SQL injection, which we'll do in the projects. SQL injection makes it easy right through a web browser to dump all this email and all the data on a server, and it was responsible for something like 99% of all the stolen data until about 8 years ago when Amazon put up these online thing called EC2 storage buckets, which by default are visible to everybody. So everybody that moved to the cloud and wasn't careful exposed all their data to the whole world, so that managed to lose even more data and become an even bigger problem than SQL injection. So that's why we're all here. That's why security is such a madhouse, because we're losing. It keeps getting worse and worse. Everybody's data keeps getting lost over and over. Nobody is safe. The Pentagon gets hacked, Google gets hacked, Microsoft gets hacked. That's why there's a huge demand for security professionals. We're all so bad at our job that they keep needing more and more of us. There is no good solution, really, but there is a current belief that hiring trained individuals to protect you makes you safer. We can't prove how much benefit it's doing, but that is the belief, and therefore we're training people in security, and they're getting jobs in security, at least until recently. As you probably know, a couple of years ago, Elon Musk fired 80% of everybody at Twitter, and that started a wave of layoffs through the industry. Everybody cut their staff by 20 or 30%, and then there was Doge that in just a few months laid off something like 200,000 government workers, so all the job market is flooded with experienced professionals at every level. So it's very hard to find a job right now, because a lot of people are just going back for more education since they can't find a job, which is a pretty good response. So you'll see people claim their site is secure, a very frequent claim. The fact is, professionals would never say that. You cannot claim a site is secure. You can make a much more careful claim. Like, consider your physical security. How do you know when you walk down the street somebody isn't going to shoot you or rob you? How do you really know? How could you claim to be secure against that? You don't know that. Now, you could have a bodyguard with you or a suit of armor or something, or an armored car, and that would be better, but it's not completely secure. There's ways to get through all this. All security is a approximate thing, like health. There's not a state called perfect security. There's a condition of security where you are safe enough that you can accomplish things. So a business is considered secure enough when they can actually perform their business and make money and make the payroll. They're not getting hacked so often and so badly that it shuts down the business. And a town is considered secure when people can mostly go out to the store and go to a movie and have a good time, and they're not too often getting killed and robbed. But in neither case does the crime go down to zero. So you just have, it's an approximate condition. So here's these guys that claim 100% secure online voting because they use blockchain. Anytime anybody claims to be 100% secure, that means they're an idiot. They don't even understand. There is no such thing. A real security professional would never make a claim like that. That cannot be achieved. No amount of money can ever make you 100% secure. All right. And so here's an example from your textbook. They're talking about how many flaws they found on the web. And the most common one is cross-site scripting, but there are many others: information leakage, SQL injection, and so on. There's just a lot of flaws in websites. So when you send your data to a website, you should be aware that the person you're sending it to is likely to just store it somewhere unsafe and lose it. That's a fundamental problem. So there's just a lot of them. Here's one: an unauthenticated request would let you dump down people's data from the server. We'll have many such things. You just get a response here that has all the information that you weren't supposed to be able to see. This is very common. And so OWASP is the Open Web Application Security Project. This is a group of volunteers from all the major companies that get together to help define standards for security on the web. And it's pretty much at the heart of what we're going to do in this class. And they publish a list and update it every few years. And here's what it looks like: weak server-side controls, insecure data storage, not protecting data in transit, having data leak out from requests. These are various kinds of vulnerabilities. These are the mobile top 10 risks that apply to phone apps. And they have another one that applies more specifically to web apps. But mobile apps are very much like web apps. And I'm teaching a class on that this semester too, meets on Wednesdays. And I went and tested a whole bunch of Android apps, and I found that they are very vulnerable. Even the ones from the top 10 banks, insurance companies, and stockbrokers are all vulnerable. And when I reported the vulnerabilities, they didn't care. Most of them didn't fix it. Although, to be fair, like 8 years later, one of them actually hired me to teach their coders to write more secure code for a while. So anyway, and I went and did websites at colleges, and I found a bunch of problems at colleges. A bunch of them had malware on them selling drugs from the college website, and exposed data and SQL injection. And in general, I found here what the professionals had told me: if you go to somebody's website and find a security problem, if the only question you should ask yourself is, do they have a bug bounty program where they'll pay you? If they do, then tell them. If they don't say anything and let them get hacked. That is the professional thing to do. If you try to tell someone that doesn't have a bug bounty program about a problem, it will do no good. I reported hundreds of these, and the number of them that actually fixed the problem is 2%. And a bunch of them will then try to accuse you of hacking them and punish you and hurt you. The fact is, if they're not smart enough to have a bug bounty program, they're too stupid to understand a vulnerability report. They will just think you're attacking them or something. I've done it a lot. It's a lot like political activism. You're trying to tell somebody something they really don't want to hear, and they just get mad at you. It's an exercise in masochism. I benefit from it personally because when people ignore these problems, they become homework. So I was using those sites as test sites for my students to practice finding security flaws. But otherwise, there's no benefit in telling them. They don't fix it. They don't care. Anyway, all right. So that's the core problem. Like I said, core problem is users can send data to the server in many ways. Parameters are like your username and password. There's cookies. There's headers in the HTTP request. And the problem is it's mishandled at the server, and also developers often do not understand. Now, if you consider something like, I open up a website here like Amazon. Let's go to Amazon. Okay, I go to Amazon and I see all these products. I might click on one and buy it. Then you might ask, if I click on this and buy this product, where is that data being processed? What machine is doing that? And the answer is some of the processing is happening right on my machine in my browser. Some is happening on the first Amazon server. Some is happening on other servers. Some of this data is coming from third-party servers like advertisers that are putting ads on the page from third-party companies. You can't say which server is handling the data, and the developer that writes the website also typically does not understand where that data is being processed. It's confusing, so they end up putting a security barrier, like customers have a special they can only buy up to 10 items. They enforce that 10, but they often don't realize that 10 is being enforced in JavaScript in my browser, under my control. So those are called client-side controls. Often important things are enforced on the client side where I can turn that off, not on the server side where they should be. And that's a very easy mistake for developers to make, and they do make it all the time. So you could change the price of an item, go into somebody else's account so they get charged for it, go to SQL injection. And by the way, just using HTTPS doesn't stop any of these. That just encrypts the data in transit. So a person sitting next to you in a coffee house picking up your radio signals can't read it. That's all HTTPS does. It doesn't stop all these attacks, which involve sending data to the server, which is then misunderstood at the server side. All right, so like I say, the fundamental problem is all the developers at all the various levels, and for that matter, the end users are not very educated about security, and they don't really understand how it works, and don't really understand the risks they're taking. So, by the way, I should also mention if you have a VPN, VPN's advertised, get a VPN and you'll be safe. All a VPN does is encrypt your data in transit and conceal your location. So a VPN is useful. I use VPNs to get around content blocking, and some people use them to get around geographic blocking. But that's about all they do. They encrypt the data, don't stop any of the major attacks, because once the data gets to the server, it's decrypted and has the effect. And most of the attacks rely on data being misunderstood at the server. So be aware, a VPN adds a little security, but it doesn't actually stop the major security threats. And it's exaggerated in a very deceptive way. They say, oh, you're totally safe because you use a VPN. Remember, you're not safe. Remember, the number one threat most likely to hurt you is not technical at all. It's social engineering. It's a human fooling you. You got a tax refund coming. The courts are coming after you. Tricking you at a human level is your number one risk. And no technology is going to stop that. Anyway, so that's the perimeter. There was a time, notably up to 2002, when Microsoft officially said all you need is a firewall on the edge of the network, and inside your company you'll have these machines in a trusted area and you don't have to worry about their security. That's all over now. Everything is porous. Everybody has smartphones and thumb drives and everything. So there's no actual constraint on data entering your supposedly secure network. So you have to have security at every device. And the modern recommendation is what's called zero trust, where every request going to a server, even from your internal devices, is screened to see if it looks suspicious, because any of your internal devices could be infected or compromised, and you have to consider that. So, all right. And anyway, many of the old flaws do get better and better as years go by. Number of vulnerabilities in major products do go down, but there new attacks appear too. So right now, one huge issue is Internet of Things. There's a product called Run Zero that scans your network to find out how many gadgets you have and what they are. And it has a free version that only goes up to 100 gadgets. And some of my acquaintances on Pulse Security Weekly podcast said they're running it at home and they're already up to 88 devices in their home that are on the internet. They got a smart thermostat and smart light bulbs and a smart refrigerator. And, you know, I don't have a smart anything. When I scan my network, there's like 2 devices on it. But I'm a Neanderthal. Other people have all these smart garage door openers and everything. And each one of those gadgets is a possible attack point into your network. And most of them are made very badly and not very secure. So it's increased attack surface. Anyway, all right, so I got a Kahoot. These are online quizzes I do just sort of for fun. You get extra credit if you get the highest score on the Kahoot among the top 3. And the main thing is it helps stop people from falling asleep. I learned this from the U.S. Air Force. They have a training product called Cyber Patriot that we do, and they use Kahoots. And I said, these things are great. They're intended to make the class more fun. So once I defeat all the security barriers and get in, I'll be able to present this, you'll be able to answer online, and it rates you on both the, hey, my stream doesn't seem to be going. Well, it says it's streaming. Maybe just refresh this browser. Oh, it looks like it is going. Good, okay. Good, all right. That happens sometimes. If you're remote, Twitch freezes up sometimes, and usually just refreshing your browser will make it unfreeze. All right. So I should have chapter 1 here. There we go. All right. There we go. All right. So go to kahoot.it on any kind of device and put in that number and a name you want to use. And like I say, you can get 3 points by being in the top 3 here. So it can add up to a bit after a while. And it mainly stops people from falling asleep. Of course, this is optional. There's always some people that don't like it, but most students like it. And it's extra credit because, of course, it's not particularly fair or anything. I don't know if people are talking to each other, handing over answers or anything. That's what only counts as extra credit. This is not, the quizzes are individual online. All right, let's give it a shot. All right, so what makes Web 2 different than the early web? Yep, user-submitted content is the new thing. Things like Facebook, where you're uploading data which came from random users and not just putting up data that came from your developers. All right. And that, of course, involves scripting. There were some scripts before, but they're mainly used on the modern web. All right. All right. All right, what does SSL stop? It stops the data modification. Now, cross-site scripting, SQL injection, and cross-site request forgery are all attacks which you'll perform later in the course that involve sending data to a server which is misunderstood on the server side. But man in the middle means intercepting the signals you send and modifying them so false signals get sent. Like you can intercept a request to buy a product and change the address so it goes to you. Hello?
May I ask you a question?
Yeah.
Sorry to interrupt.
What's up?
I was listening to Revit class and I went upstairs and there was literally nobody.
Oh, what course is it?
It's Revit.
Revit?
Revit. It's like a program.
I don't know anything about it, I'm afraid. I,
Instructor Solara Shri. Sorry if I butchered this. Shri Laran.
I don't know that person. I'm afraid I'm useless. Just go on the website and see if you can find an email address to contact.
Yeah, I did. Okay, I was just wondering.
Yeah, I know. It's a good bet. It's news to me. I didn't even know we we're training anybody in that
This is
problem.
Cloud Hall.
This is not cloud. This is science. Cloud's a different building. That's the problem.
Oh, okay.
Yeah,
Somebody told me to go here and I was like.
that's the problem. Yeah, Cloud Hall. You go across this where the flag is. Yeah, go over that way. Good.
Thank you so much.
Good. That makes a lot more sense. Okay, good. Thank you. Good. All right. So anyway, it stops this. The point of SSL is that it encrypts your data, so if somebody intercepts it, they can't decrypt it. So they can't read it and they can't modify it and send it forward. All right. Anyway, we'll keep going. All right. What's the most common website vulnerability? Cross-site scripting is by far the most common vulnerability, and most companies don't take it seriously because you can't hack into the server with cross-site scripting. All you can do is attack other users, and they regard that as not their legal responsibility. However, most websites do have this flaw, and it's part of attack chains, and we'll use it in the projects. You'll learn how to steal people's data with cross-site scripting, how to get into other people's accounts. And the most important defense method. This is an interesting one. That's interesting. You're getting it right. Usually most people used to think it was antivirus. Now I think most people have kind of come to realize that antivirus is not that. It is updates. Updates are your most important method defense, because what happens is it gets to be a known vulnerability, and if you don't patch it, there's a known easy way to attack you. So these are the most important things to do to secure yourself. This is why Microsoft is always trying to get you to put on your patches, and Apple and everybody, because that is usually your strongest defense. And it's not all that strong, but that's the best. All right, anyway, all right, good. Oh, you see you won, that's right. I should be making a note of this. Get my place to put notes. Jason's probably a fake name. Like I say, if you're going to use a fake name, you get 3 points, but only if you tell me who you are. And Jeffrey Y might be a real name. All right. That's Jeffrey Y, right? Yep, Jeffrey Y. Okay, Jeffrey Y. Bill might be a real name, but there might be more than one Bill. Jason, I bet that's not a real name. So if you care about getting your points, tell me. Anyway, this is Cahoots. All right, so let's go on to the next part of the chapter. I plan to have everything done by 7:30, and I think we'll make it. All right, so defense mechanisms. One thing you can do is limit users' access to things. Don't let them get at things they shouldn't go to. Limit their input to stop dangerous data from coming in. Frustrating attackers, and monitoring and noticing when people are attacking. These are common defense elements. So in order to control what users do, you have to have authentication, session management, and access control. Authentication is determining who somebody is. So username is identification, claiming to be somebody. Authentication is proving that somehow. And the cheapest, least secure, and most common solution is passwords. Everybody has a password, but as you know, passwords are not very safe. They get stolen and leaked all the time. It's a lot better to have two-factor authentication. You have both the password and something else like an app on your phone. But anyway, that you have to have some kind of proof that you are who you say you are, and you can't really control what users do without figuring out who you are first. So first you authenticate people with some kind of login function, and then there's common problems here. People can guess the password or steal it, or there are logic flaws that let you somehow break into someone else's account. There was one at Facebook where if you tried to reset your Facebook password, it would send a long random string to you, and that random string was findable on other people's pages, so you could get into other people's accounts. This kind of thing tends to happen. All right, session management is the next thing. As I mentioned earlier, once you've logged in, how do I remember who you are? Since the web server forgets, you have to keep sending proof up, and that means I have to maintain a session, knowing who's logged in and who you are all the time, typically done with cookies, and that also tends to have things go wrong with it. One common one is people use a public machine like this, they log in, they walk away, they close the browser, and they don't know that that doesn't end the session. So when the next student opens the browser, they're in somebody else's email account. You could call that a failure of session management. So you might be able to predict those identifying tokens or handle them poorly so someone can steal them. That's commonly a problem. And then access control. Once you've figured out who somebody is and you've remembered who they are, then you have to know what they're allowed to do. Normal users should only be allowed to get into their account Administrators should be allowed to get in many accounts and so on. And you have to, every request on the server should check to make sure the person doing that request is in fact authorized to do what they're doing. And this is extremely common that people fail to do this. Open APIs is a very common problem. Application programming interfaces on the server are a series of requests you can make to the server, like log in, create an account, make a purchase, change an address. Each of those will be what's called an API endpoint, and you send a request with a different to one of those points to take those actions, and very frequently there's one of those actions that forgets to verify who the user is before letting you do it. And someone who has not properly logged in, like the administrator, can do something like dump out the data or erase data. That's a very common flaw. So the most common thing people do is limit the data that comes up. They only have a certain number of characters or certain types of characters allowed in a field. The problem is most of these enforcing is done on the client side, and you can just turn it off in your browser. So all these things are sending data up to the server, and that each one of them might contain dangerous input. So one procedure that's commonly used is called deny listing, is the modern term for it, where you try to list all the bad things and block them. You don't want to use them send select. But the problem is you have to consider other things which will be understood that way, like mixing uppercase and lowercase characters. In SQL injection, you often use this phrase, 1 equals 1, and if they block that, you can try 2 equals 2, which has the same effect, but might not be caught by the filter, and so on. It turns out this is why deny listing is considered a very weak defense, because you list all the bad things, and all the attacker has to do is be creative enough to think of a new way to rephrase the bad thing that will bring it through. And especially, as I mentioned, the worst case is large language models, AIs, where you can say something many, many different ways, like in a strange language, in invisible text, with different words. There's no known way to stop the bad things from getting into a large language model, because there's an infinite number of ways to rephrase things. And the other thing is allow listing. This is much safer, where instead of trying to eliminate all the bad things, you decide what things are good and only let them in. Like you only let in letters and numbers, no special characters, something like that. That'll stop a whole lot of attacks, that sort of thing. This is much safer, but the only known good input is accepted. What many websites do, unfortunately, is they sanitize data. If you send them data including attack characters, strange characters, they will just filter them out and then keep using the data. It would be a whole lot safer to just refuse to do business with anybody that is sending you attack traffic. Just say, get lost, and start over again, rather than cleaning up the data and trying to use it. And yet a lot of people do this, and that makes it, then all the attacker has to do is experiment with different versions of malicious data until they find one that slips through the filter. All right, so what you'd like to have is safe data handling. You'd like to have your scripts on the server written in a way so that they cannot be fooled. For example, parameterized queries in SQL injection, we'll talk about this, is a way to design servers so that they cannot misunderstand data and have SQL injection happen. This has been known for years. So if you write more secure code, that is the best solution. The problem is that requires retraining your staff and monitoring them so nobody uses the old techniques that are unsafe. What most companies do is that runs too much bother, so they buy a web application firewall in front that supposedly stops the bad stuff, and then let their staff continue to write insecure code behind there. And that makes them more vulnerable, but it does mean you only have a controlled amount of expense, and it means you'll pass certification tests to get certain ratings, where tests in your firewall will meet the standard. So from a management point of view, that is a security measure that is easier to understand and control than training your staff, which is hard to do and hard to measure the effectiveness of. Anyway, all right. But the problem is, of course, some malicious input does not have any bad characters. Like I get an account number, but it's somebody else's account number. There's nothing malicious about that in principle, but it can be a bad thing. What you really have to test is this number acceptable in context? Does that account number match the currently logged in user? So that's, we talked about this. And so if you consider it, you have a lot of trust boundaries. Anytime one server connects to another server, you have a boundary where data is coming out of one system and going into another system, and you have to inspect it to see if it's malicious. That's where you approach the modern solution of zero trust, where you really should test data every time it moves from one system to another. That's what we're all trying to get towards, although right now the only product you can buy that does that is Zscaler, and it is very expensive. Only the largest companies have it. All the rest of us are in the early stages of trying to move to a state of zero trust where every request is filtered and examined as it moves along your network. All right, so that's the game. This is our goal. Each component should take the input and not trust it, and instead inspect that input to see if it looks dangerous or forged or anything before using it. You see this, for example, with credit cards. And by the way, this keeps happening to me with YouTube. I'm traveling to conferences. YouTube kept freaking out. I would go to a conference and log in from there and put up videos, and they say, wait, it looks like somebody's hacking your account, putting up videos. And they kept on like freezing me out, making me log in again, making me go through a list of videos they think should vanish because they think someone else put them up because it's suspicious data coming up. And the same thing with credit card transactions. You know, if you're an American and suddenly there's a large purchase from China, your credit card company will freak out. Wait, that looks like an attack. It might really be you. But, you know, that's logical. They're looking for suspicious transactions. And in the world of zero trust, all the data transfers should be subjected to an inspection like that to see if it appears to be messed up. So you have the user come in with a login, then they send a SQL query to go to some database to see if a product is available. That goes to another database server. Then they go to some application server to do something else, and they send what's called a SOAP message, Simple Object Access Protocol. And so all these messages from one server to another really ought to be inspected to see if they look suspicious or malicious. That's the plan. And SOAP is just a HTTP-looking way of requesting data from a server. We'll play with it in the projects later. Anyway, so I've summarized this. You go to the various steps. So if you try to filter something out, like you're trying to remove script, because this is something a normal user shouldn't be putting in, like a username or a Facebook message, but the attacker can send this, and then when the script in the middle is removed, what remains is script. So you can't do just one pass of removal, or it won't be effective. This is one of the many tricks. Another one, if you're trying to stop directory traversal, where you do .. to move up to a higher directory and go to a directory you're not supposed to be in, you could try to remove this and then remove that. But if I could send a pattern here where you'll remove this, leaving that, and you've already passed the test for it. So this is the problem. Like I say, there are many, many clever ways to put things in where even sites that attempt to filter out a known bad string will not succeed. And then there's canonicalization. Things sent to the server in URLs, web addresses, you can put in percent and 2 digits, and that will send that raw hexadecimal, 2-digit hexadecimal character to the server. So you can encode things this way. This is called canonicalization. And so you can send it up that way. And early versions of Microsoft's web server decoded things twice. So you could send this string, and that would turn into an apostrophe and pass the filter that was trying to block apostrophes. This is the kind of thing that tends to happen over and over. Users come in, and so you should notice when errors happen and do something intelligent about them instead of just ignoring them. You should have logs. There should be a way to alert people that you're under attack. So you have unhandled errors. We'll just pop out data here. Years ago, I used to test a lot of websites, and I tested a Democratic Party website, and it was fine. And I went to a Republican Party website. I put an apostrophe in the URL, and the whole page filled up with screaming red ASP error messages. And I said, I think I'll leave this alone. These guys will probably freak out. But this is pretty common. Even a small error, it'll just dump out an uncontrolled error message, and this is bad. Not only is it a bad customer experience, like having the lid fall off a car and you see the engine, it also exposes internal data. Your website should control errors. It should put up an orderly error message. I can't find that page, here's our search engine, or something like that. If it just spits out a bunch of source code from the server, that's bad. Audit logs record all sorts of things, and a lot of audit logs are publicly available. There's a thing called an ELMA server that had a lot of audit logs, and unfortunately, the audit logs include the whole web request, including the authentication cookies. So you could just send, Toyota had this for a while, you could just send someone a tweet or instant message with a Toyota URL they would click that had like an apostrophe in it, and when they go there, if they're logged in a Toyota website, it would make an error, including their authentication cookie, which you could then examine in the public logs and steal their cookie that way. People don't always think that logs are something they need to secure, but there's often information in the logs that is in fact confidential. So you should be protecting them. Or adjusting your apps not to put sensitive data in the log. Realistically, you better do both. And when bad things happen, you should be alerting administrators you're under attack or turning on automatic defenses. This is what SOAR does, orchestration of defenses, a Splunk product that automatically detects attacks and automatically stops them. All right. And so web app firewalls are the firewalls intended for this. Most of them are pretty simple. They just look for a list of known bad attacks. And that does some good, but it's pretty easy to punch through them. So when you find attacks, people are trying to get in, it would be a good idea to have automated defenses. This is what Zeek does. Zeek is the firewall, more than a firewall. It analyzes defenses and you write a script. And so when I saw a presentation on this, when it was new at UC Berkeley, they developed it was called Bro, and they said, we don't have any static firewall at all. We just use Zeek. If it detects malicious traffic coming from anybody, it just blocks that IP address for half an hour and then lets them through again. And this turns out to be very effective. Anybody that sends junk, we don't talk to them anymore for a while. They say that's pretty effective at stopping attacks. All right. And there's a management interface for your website. This is what the U.S. military uses. The U.S. military had their first bug bounty program a few years ago. I was in it. I didn't win anything because they used PHP Nuke for everything, which I didn't know much about. This is a web development platform. And anyway, it has an administration panel where you log in and then you can put up web pages like, many other things like there's Drupal, and a lot of these things, these content management systems. And these management interfaces are often vulnerable. People can get in and it's considered best not to just expose them to the whole internet, but only allow your real administrators to access to them. But often you can attack the administration panel itself and find ways to hack in and then control the website. This is commonly how you hack into websites. You get into the administration panel and then you can upload malicious content, malicious scripts, unauthorized content. All right. So that's it for chapter 2. I got one more Kahoot, and that's all the textbook material I plan to talk about today. Chapter 2 should be here somewhere. This Kahoot thing is very nice, but it's not entirely user-friendly with the not being well sorted. Oh, there it is, chapter 2. All right. Good. All right. No new questions from the online folks. Record a professional podcast in this room, they get really mad at that noise. Yes, it is. But it was worse. For a year, we had no heat at all, and it was really cold. And I was wearing like 3 pairs of pants and 2 coats, and students were showing up wearing a full wetsuit and stuff. This is better than that. Like I say, there's a reason why classes are cheap here. The infrastructure is not too good. However, it might contribute to reasons people prefer to tune in online. Anyway, all right. It's usually not this loud. And it's a warm day. I don't know why they had the heat turned on today anyway. All right, let's give it a try. All right, what does logging in do? That's authentication. You're proving that you are somebody. All right? All right. How does the website remember who you are? sending some kind of token that tells it who you are with every request. All right, how about writing code that can't be fooled? That would be nice. That's safe data handling. All right. A desirable thing, not terribly easy to accomplish, and by the way, typically not provided by large language model automatic code generators. They tend to create unsafe code because they've trained on just all the data they found on the web, and a lot of that data was not very well written. You could make a large language model and carefully train it on very good code, and that would be nice, but that's not how the current generation has been made. Anyway, all right, what process removes malicious portions of input and then uses the remaining portion? That's called sanitization, and it's not a very secure practice, but it's very commonly done. All right. Gotta get that now. All right, I'm having trouble finding it. All right, it's somewhere in my browser. All right, what's going on here? Oh, there it is. It's full, in fact, it's full screen is following me. So I'm gonna make it smaller so I can record the names. There we go. All right. All right, so Shabi, that looks like a real name. Connie might be a real name too. And the third one is Bill Thompson. That also looks like a real name. Good. All right, good. So I got my winners. I'm going to stop the recording.